Hello everyone, myself Dr. NCH Ramgopal, working as Associate Professor in Mathematics in the Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. I welcome you all today's presentation on Complex Integration Part 2. Today, I am going to evaluate some line integrals of a given function of complex variable. That means, we are going to evaluate integral f of z dz, where z is x plus iy, then dz will be dx plus I dy. Along a curve C, the line integral means the evaluation of integral along a curve or a line. So, this curve C will be given in the problem. Using that curve C, we find the limits of integration. Here we have two variables, but we are evaluating line integral, that means single integral. It is possible only when there is one variable. So, here we transform either x to y or else y to x or both x and y to some other variable t or theta, etc. Let us solve some problems on the complex integration, particularly the line integral. Now, the first problem, evaluate integral c z bar dz, where c is the upper half of unit circle mod z equal to 1, taken in clockwise sense. So, here we need to evaluate integral c z bar dz. What is z? X plus iy. Then z bar will be x minus iy, simply replace I by minus I, and also dz is dx plus I dy. So, we need to evaluate the integral along the given curve C of x minus iy multiplied by dx plus I dy. Now, what is the given curve C? The given curve C is a unit circle mod z equal to 1. It is a circle with a center at origin and radius equal to 1. That is why it is called unit circle. And we need to consider the upper half of that unit circle and in clockwise sense. So, let us draw the graph of the given curve. So, we need to consider only the upper half. So, this part. And here, if I consider this as A and this is B and this is some point P, we need to evaluate along APB. The curve C is in this direction, clockwise sense. So, APB. That means from A, we are moving towards B in clockwise sense. So, A to B. Hence, here we use the parametric equations. I consider x as cos theta and y as sin theta. And since we are moving from A to B, theta varies from pi to 0. Here actually this is the, in polar form, this is theta equal to 0 line. This is, here the angle is pi by 2, here the angle is pi. So, pi to 0, theta changes from pi to 0. Hence, we need to evaluate this line integral by taking x equal to cos theta, y equal to sin theta, and the limits of theta as pi to 0. Now, let us substitute x equal to cos theta, y equal to sin theta in this integral. Now, integral c z bar dz is equal to integral x minus iy dx plus I dy along the curve C. That curve is APB, the upper half of the units, a given unit circle. Now, we need to replace x by cos theta, y by sin theta. Then dx will be minus, what is the derivative of cos theta? Minus sin theta d theta. Dy will be derivative of sin theta, cos theta d theta. And theta changes from pi to 0. So, this is equal to theta from pi to 0, x minus iy, x equal to cos theta minus I into sin theta multiplied by dx minus sin theta d theta plus I into dy cos theta d theta. So first we need to simplify this, then we can integrate with respect to theta. Now the first one, cos theta into this, so minus sin theta cos theta d theta plus I cos square theta d theta minus minus plus again I sin square theta d theta, and the last one minus I square sin theta cos theta, I square sin theta cos theta d theta. So again simplifying this, theta equal to pi to 0 minus sin theta cos theta d theta plus, here I can take I common, so sin square theta plus cos square theta d theta minus I square is minus 1, so minus minus plus, minus into minus is plus, sin theta cos theta d theta, and here this is plus sin theta cos theta, this is minus sin theta cos theta d theta. These two gets cancelled, and we know that this value is equal to 1, sin square theta plus cos square theta is 1. Hence the final result is theta from pi to 0 I d theta. So this is I constant, integral d theta is theta from pi to 0 by applying the limits, upper limit 0, lower limit minus pi. Hence the value of the line integral is minus pi I. So using this transformation we can evaluate the given line integral along the given curve C. So using the curve C we can find out the limits of the integration, and there is an alternate method. The same problem can be evaluated by taking z equal to e power I theta. This is a transformation. We are transforming z to theta. So what will be z bar? Just replace I by minus I, e power minus I theta. Now using this z, let us find the derivative of z, dz. Derivative of e power I theta is e power I theta itself, and the inner function derivative is I, and for theta the derivative is d theta. And also theta changes from pi to 0 in clockwise sense. Therefore the given z bar dz will be integral theta from pi to 0 z bar e power minus I theta into dz I into e power I theta into d theta. So here e power minus I theta, e power I theta is e power 0, which is 1. So I into integral d theta from pi to 0. So I into theta from pi to 0. So upper limit is 0, lower limit is minus pi. Hence the answer is minus pi, which we have obtained in the previous case also. Minus pi I, minus pi I. Now coming to the second problem, evaluate integral C f of z dz, where f of z is y minus x minus 3x square I, and C is the straight line segment from z equal to 0 to z equal to 1 plus I. So given f of z is y minus x minus 3x square I, and C is the straight line joining the points z equal to 0 and z equal to 1 plus I. We know that z is, what is z? X plus iy. Z is in the form of x plus iy. So z equal to 0 means x equal to 0 and y equal to 0. Similarly, z equal to 1 plus I means x equal to 1, y equal to 1. So the points are 0, 0 and a 1 comma 1. So we need to find the equation of straight line joining the points OA is, we know the formula, y minus y1 by x minus x1 is equal to y2 minus y1 by x2 minus x1. So here the points are 0, 0 and 1 comma 1. So y minus y1 0 by x minus x1 0, y2 minus y1 by x2 minus x1. So that implies y by x equal to 1. So we have the relation between x and y equal to x. That means we can replace y by x or else x by y, or both I can consider as some t. So x equal to t, y equal to t, and t changes from here 0 and 1, 0 to 1. So we need to evaluate the line integral. It is required to evaluate integral c f of z dz, and here x equal to t, that is equal to y. So x equal to y equal to t, and what is d? That implies what will be dx, dt, dy, dt, and what is dz? Dx plus I dy, since z is x plus iy. So therefore dz will be dt plus I dt. Now using all this, t from 0 to 1, and here the function is y minus x minus 3x square, where x equal to y equal to t. So t minus 3t square I, t minus t minus 3t square I, dz. Dz means dt plus I dt. So here we can take dt common. So 1 plus I comes out, 1 plus I integral t from 0 to 1, these two cancel, minus 3t square I dt. So 1 plus I into minus 3I common, integral t square is t cube by 3, and the limits are from 0 to 1. So this is minus 1 plus I into 3, but upper limit is 1, lower limit is 0. So 1 by 3, these two gets cancelled. So the answer is minus I into 1 plus I. We can simplify this as minus I square, and we know that I square is 1, hence this is 1 minus I. Now coming to the third problem, evaluate integral over c y minus x minus 3x square I dz, where c consists of the straight line segment from z equal to 0 to I, and the other from z equal to I to 1 plus I. So here given integral c y minus x minus 3x square I dz, it is required to evaluate this line integral. And what is this c? The c is a straight line that joining z equal to 0 to I, that is one line, and z equal to I to 1 plus I. So if you draw the graph of this, you can identify exactly what is the curve c and also the limits of integration. Now first, z equal to 0 to I, z equal to 0. What does it mean? We have z is x plus iy. So x equal to 0 and y equal to 0. And z equal to I, that implies x, compare with x plus iy. The real part is 0 and imaginary part is 1. So x equal to 0 and y equal to 1. So this is from origin to some point here A, O to A. That is the first line. And then z equal to I to z equal to 1 plus I. Z equal to I, that implies just now we have written x is 0 and y is 1, and z equal to 1 plus I means the real part and imaginary part are equal here, x equal to 1 and y equal to 1. So from here to somewhere here, this is the point 1 comma 1, and this is the origin 0 0, and here x is 0, y is 1. So this, hence the curve C is first from O to A and then from A to B. So we need to evaluate the line integral along these two lines, along OA plus along AB. So therefore the line integral C f of z dz is equal to along OA f of z dz plus along AB f of z dz. Sum of these two line integrals. First one, let us find the integral one for each line segment. First one along OA. So we need to identify the limits in both according to these both lines. So along OA. So that means here O to A. Here on this OA, the value of x is fixed 0. X on y-axis, the value of x is 0. And here the value of y is 1. So along OA, the value of x is 0 and y is, we need to fix y first, and x is completely 0 on y-axis. So I consider y equal to t and x equal to 0. That implies dx will be 0 and dy will be dt. And the limits for t 0 to 1. You can see here 0 here and here the value of y is 1. But y is t, therefore t lies between 0 and 1, or t changes from 0 to 1. So therefore along OA, the given f of z dz is equal to, along OA, what is f of z? Y minus x minus 3x square I dz. And we have z is x plus iy. So dz is dx plus I dy. And therefore I can substitute x equal to 0 and y equal to t in this f of z. So first we have y, t minus 0 minus 0 dz. dz is dx plus I dy, but dx is 0 since x is 0. So only I dt remains. So this is I into integral t dt. So that is equal to I into t square by 2 from 0 to 1. The limits for t are 0 to 1. So I by 2. This is the first integral. Similarly, we need to evaluate along AB. Now along AB, it is very clear that y value is 1 and x changes from 0 to 1. So now we fix x first. Second one, along AB. Along AB, y equal to 1. That implies dy is 0. And now I consider x as t. So dx equal to dt, and the limits of t 0 to 1. So therefore along AB, f of z dz is equal to t from 0 to 1, y minus x minus 3x square I. Y minus, y is 1 minus x minus 3x square I. Now dz is dx plus I dy. So here dy is 0, dx is dt. So we need to integrate this. So integral of 1 is t minus t square by 2 minus 3i into t cube by 3 from 0 to 1. Applying the limits, upper limit 1 minus 1 by 2 minus I, lower limit 0. So this is half 1 by 2 minus I. Hence, the line integral along C is equal to along OA plus along AB, which is along OA we got I by 2 and here plus 1 by 2 minus I. So this is minus I by 2 plus 1 by 2 or 1 minus I by 2. So in today's session we have evaluated the line integral of given function of complex variable. So line integral means the evaluation of integral along any curve C. Using this curve will be given in the problem, and using this curve C we find the limits of integration. And the main point is we are evaluating line integral, that means the single integral. So therefore we can evaluate this integral with respect to one variable only, one variable. That can be either x or y or any other variable. So we need to transform x to y or y to x or both x and y to some other variable t, theta, etc. So, in the next session, we will solve some more problems on line integral of a function of complex variable. So, this is for today's session, and we will meet in the next session. Thank you.